Morning, good afternoon, or good evening, depending on where you are, and welcome to the webinar, Best Practices for Application Security in the Cloud. My name is Elise Arthurs, and I'm Director of Partner Marketing here at RightScale. And before I introduce our speakers today, I want to remind you that we have a live Q&A at the end of the webinar. So if you submit your questions in the question chat window on GoToWebinar, we'll get to those through the webinar and at the end also, so please keep the questions coming. Now I'd like to introduce our presenters today. Today we've got Bernard Golden, CEO of HyperStratus, a partner of both RightScale and Amazon. And we have Steve Riley, who's the Senior Technical Program Manager for Amazon Web Services, as well as Michael Crandell, CEO of RightScale. And on the Q&A line, we have RightScale Security Specialist Tony Spataro, and RightScale's account manager, one of many, Andrew DeMille. And please remember to submit your questions. And with that, I will hand it off to Bernard to get started.
Thank you so much, Elise. Today we're going to be talking about security and cloud computing, and obviously a hot topic. And what we really want to emphasize is that we're all in this together, and by all of us, that means the cloud provider, like Amazon, a management infrastructure like RightScale, and the end user, the application, whoever creates the application, or whoever creates the partnership, because we work with many clients to jointly create applications. But the point is, we all in this together. All of us have to cooperate and take advantage of what each of us brings to the table to make sure that applications are secure. And so we're going to, Steve is going to provide an overview of the Amazon Web Services security, the kinds of security capabilities they've got in place, and the framework that they provide that offers security that applications can integrate with and take advantage of via a management framework like RightScale. Michael is going to provide an overview of RightScale security, how it integrates with Amazon, and what it provides, the way that it manages security. And this becomes very important because when you get to any kind of a complex topology application, if you don't have a management framework that implements consistency and automates it, really it's very challenging to get good security practices spread throughout the application. Absolutely crucial. And then we're going to talk about the security best practices for applications. And again, remember, this is a shared responsibility. And so it's important that at the application level, you recognize what your security requirements are, that you define how those will be implemented through Amazon and RightScale, and that you integrate them in a way that takes advantage of those things. So it's really crucial that there's a role for the application and the application creator, and that has to be designed and implemented. So with that, let's move on to the first slide to kind of talk about the overall ecosystem or the overall environment for security. And you don't have to be around a long time to understand that security is the biggest issue slowing cloud deployment. People love the idea of, how do I take advantage of cloud computing? How can I have someone else take responsibility for the infrastructure? How can I leverage the ability to get very elastic, scalable resources available on demand? How can I reduce my costs? How can I write applications that really make it easier for me to get functionality to market? Everybody loves that, but they say, what about security? That's the thing I'm concerned about. It is definitely the #1 concern. It happens all the time that people say, I'm ready to do it, but what about security? And because of that, they end up being confused. And they end up sort of being confused about, well, who's really responsible for cloud security? Is it the cloud provider? Is it me? Is it some combination? They're not really exactly clear. And the truth is, it's a shared responsibility. We'll be talking about that on the next slide. But one of the crucial things that holds people back is they say, well, even if I understand that there's some shared responsibility, what are the best practices? How do I best take advantage of what the cloud provider offers? Or how do I know what to design into my application? How can I determine that? And there's really a lack of guidance in best practices. And during our portion of the webinar, that's what we'll be talking about. How do you create and implement these best practices? We've worked with both Amazon and RightScale to define a set of best practices, a set of standard kinds of security mechanisms you should put in place. I'll be talking about that during my portion of the webinar. And with that, if we could move to the next slide, that would be fantastic. So what we're going to do over the next 60 minutes is talk about the 6 key best practices area of application security. We're going to talk about the techniques for layered and application group security. So we're going to talk about the different layers that the cloud provider, the management layer, and at the application take on. Amazon will be talking about their infrastructure and security framework, and RightScale will be talking about how to manage and automate security consistently. Next slide. Okay, so just to introduce HyperStratus, give you a little bit of background about kind of why we're here speaking with Amazon and RightScale. We are a education consulting company as a system integrator. We work with enterprises primarily and also with cloud vendors. As I said, we're a partner of both Amazon and RightScale. We've worked with them to define these best practices, have reviewed them, talked about security with them, ensured that our best practices reflect the best practices into their offerings. A set of proven methodologies and 6 security essentials. We'll be talking about that a little bit later in the presentation. Let's go on to the next slide. Right. Well, so security is a shared responsibility. And this is, if you take nothing away from today other than this, it's important to understand that essentially getting an application to be secure is a shared responsibility and requires all parties to be participating and implementing their best practices or taking advantage of what they provide. The cloud provider, Amazon Web Services, provides an integrated application with the infrastructure and management security framework. In other words, Amazon provides a set of security capabilities that is the way that applications implement security. You have to take advantage of those. You have to understand them. You have to follow their recommendations. And you have to take advantage and design your application so that it integrates well with them. The management layer implements consistent and automated security practices. Applications can get very complex. We've done applications with as many as 50, 60, 70 instances running. There's a lot of different instances, a lot of different piece parts. You have to make sure that, at that scale, you have to make sure that you've got all of these instances with the right level of security put in place, the right practices, the right definitions, the right settings, configurations, and so forth. And when you get up to that number of instances that you're coordinating, you really can't rely on manual doing that manually. It's just too complicated. It's too error-prone. It's too likely to leave you exposed. And it's really crucial to have a quality management framework like RightScale in place. And then, from the perspective of designing the application, which is where we come in, you really have to make sure that your best practices, your security, your application design integrate with all of those in the proper way. And that keeps you protected. And that's the ultimate goal, right? How do I keep my application secure? Let's move on to the next slide. I think we're ready to move on to Steve, and he's going to talk about the way Amazon brings forward a security framework.
Okay, thanks, Bernard. And I want to thank everybody for joining us on the call here today. I'm hearing an echo come back. I don't know if somebody's speakers and microphone talking to each other. There, it's gone. Great. I have 2 parts in my part of the presentation today. First of all, I want to try to introduce a new way of thinking about security. I'll take a couple minutes to go through that. And then the second part of my portion of the webinar today will be giving you a little bit of the details of some of our internal controls and processes around what we do to protect the integrity of the information that you entrust to us. So let's start with some conceptual things. And what I want to try to do here is, in the minds of all of you who are listening today, begin to have you rethink your approach to security. Traditionally, we've approached security through thinking in this kind of a model where if we knew where information was, that means we could point to its location, and then we could make an assertion of who owns that information. We could then claim that we were in control of that. Here is my stuff. It's secure. That stuff over there, it's not mine. It's not secure. We're all very familiar with this location-based model of security. And that helped us build layers of trust because we knew where our hardware was, we knew where our software was, we knew who our people were, and from that we could then build perimeters that separated trusted information from untrusted information. I am proposing that this model is breaking, and it's breaking because we're seeing a change happen that we've not seen in the IT industry before, where we have a re-centralization of compute and storage, but a decentralization of access. So being able to say that you know where something is really not, it doesn't mean a whole lot anymore. We can't take that very seriously. And if location doesn't mean anything, then location-based security models are breaking apart. So I'm going to propose that we redefine control, that we measure security through a few different mechanisms here. And the three mechanisms that I propose are encryption and signatures, service level agreements, and auditable security standards. If we redefine control through these three methods, then we can still say that we have secure information, we have control over that, without necessarily having to know about where it is physically. Now let me help you think for a moment. You already know this model when it comes to VPNs. Nobody here on the call can say that they own the internet, with the exception of maybe some telcos, but then you own that portion of the internet, of course. But for all the rest of us, we've been very comfortable giving up ownership of the pipe. We apply encryption, security standards, and service level agreements, and we retain ownership of the data in the pipe using a VPN. I propose that we can do the same thing with compute and storage by using encryption, security standards, and SLAs. We can give up ownership of the physical assets, but still retain control of the data. It's the same logic. We're simply applying it to a different portion of the physical assets now. So there's the thinking that I'd like you to start to at least mull over a little bit. And with that, I'd like to go a little bit deeper into what we're doing at AWS to help safeguard your information. We have physical facilities in 4 areas across the world: Northern California, Virginia, Ireland, and Singapore. In each of these locations, we have the compute facilities, the storage facilities, and then in 15 other locations around the world, we also have content distribution a product called Amazon CloudFront. Let's take a look at what we have in US East, what we call it. In US East are 4 availability zones. Think of an availability zone as a physical data center. Each one is distinct from the other. And we do take some measures to make sure that some act of nature in one place, like say a fault or a flood, doesn't affect other availability zones. So as much as possible, we isolate them geographically. Easier to do in Virginia and California, as you imagine, than it might be in Singapore. So that's why in the other areas, in Europe, Asia, and in North America and U.S. West, we have at least 2 availability zones. And that is our minimum requirement for any time we locate physical facilities, that there must be at least 2 availability zones. Having these multiple availability zones allows us to increase the durability of the information that you provide. Depending on the service, we will frequently replicate information within a single region across multiple availability zones, and I'll get into some more of those details in just a moment. But one of the things that I want to help make sure that you understand is that we do not, under any circumstances, automatically move data between regions. So we don't take data that you've placed in Europe and move that into the United States without your permission. You actually have to initiate those data transfers. And the reason why we do that is it helps you achieve certain regulatory compliance requirements. If data has to be located in Europe and can't leave, then you can do that, and you can rest assured that we're not going to take that out of Europe at all. You have to make that move. A little bit more about an availability zone. They are nondescript buildings. We don't put any signs on them like you see here. We don't advertise that this is a fact, that there's a lot of very valuable customer information here. We have very strict controls over who can go in those buildings. You have to be an AWS operator who's been granted permission to do something on a particular cage. You get a time-limited token, and all access, all physical access to those environments are logged, probably on this ancient dot matrix pattern that you see right here. No, it's actually, it's better than that. Now, let's talk a little bit about the durability that you get. The durability you get is dependent upon the particular services that you choose. When you store data in Amazon S3, in Amazon SimpleDB, or in our new RDS Multiple AZ, which is out on the slides here, we will make multiple copies of that across multiple availability zones within the region that you specify. That happens automatically as a feature of the service. We do that to give you that very high durability. And if you then want to read an object that you've written, and your request for that object happens to land on a disk that dies right at that moment, well, we'll go grab it from another disk and send it to you. You don't even get an error message. Data that you store on the Elastic Block Store volume or on single AZ RDS, we do still make multiple copies of that, but it is only in the availability zone where you store it. Data that you store on disk attached to a compute instance is, of course, not replicated. That's why we call it ephemeral storage. It is not storage that is intended to be durable. It's just what the operating system boots from. You should never use this as a repository for your database, for example. Now let's take a look at what we do on the compute instances. We use the Xen hypervisor. That's our base. We make a few modifications to it. The most important modification is the functionality for the security group. Think of a security group as a software firewall that allows you to define the traffic that's allowed to come into a box. That code actually lives in the modifications that we make to the hypervisor. In order to make sure that that code itself is secure, we do our own routine internal penetration testing as well as hire an external penetration testing firm to validate the security of that software on an ongoing basis. That allows us to then help you understand where the divisions of control lie. Our operators have access, of course, to the physical machines and to the host operating system, but we have very strict policies as well as technical controls that prohibit the operators from seeing what's happening inside a virtual machine. Only you, the customer, has ownership of the virtual machine. And furthermore, you have admin control of that. It is your VM. You can do whatever you wish with that machine. We do not have any restrictions on what you can do with that. Now, a little bit about the storage that we use. When you attach an EBS volume to an EC2 instance, you'll note that there's a bit of a delay when you allocate that. That's because at that time we are zeroing out those disk blocks. You get fresh, clean disk when you use an EBS volume. For the ephemeral storage on an EC2 instance and for all of the rest of the services, our approach is slightly different. What we do is create a logical to physical block, logical to physical block mapping that ensures that you can only read back data that you have written. If you shut down an instance or if you erase a database, then we immediately destroy that logical to physical block mapping, and there's no way that we can recover the data after that. We could pull the disk out of the frame, we could look at the bits that are there, but there's no process that we have and no technical method that we could use to isolate your bits from your terminated instance from somebody else's bits, for example. My most favorite feature in Amazon Web Services is Amazon VPC. I'd like you to think of this as an extension of your data center into our cloud. These instances are not publicly accessible because they don't have publicly accessible IP addresses. You assign the IP address. You assign the routing from a router on your network to a router on our network. And the only way these machines are discoverable is through the routing environment that you create. If you want them to be accessible via the internet, you actually have to expose them through your firewall. So they're controlled with your security procedures, your intrusion detection systems. Whatever you want to do, you can join these machines to your domain. You can use any management system that you might own. These VMs literally are yours. They just happen to live in one of our data centers and benefit from the high durability and high reliability of that. One of the most important planned features coming up for VPC very soon is adding the ability to connect multiple customer routers to a single VPC. This is great for corporations who want to have a bunch of small branch offices but no central headquarters. Your central IT actually lives inside AWS, and each of your regional offices will be able to connect to your VPC. That feature is coming soon, and we'll be sure to make an announcement when you can take advantage of that. We've also added, this is not so new anymore, but I still like to talk about it. Because we believe that data protection is so important, we are looking at ways we can help you enhance the protection of that data. And several months ago, we added multi-factor authentication. This requires a security token in addition to a user ID and password in order to log into the management console. We're going to be extending this so that the services themselves can take advantage of this as well. The great thing about this is that it just provides an extra level of assurance when people are manipulating the particular elements of your AWS environment. I also want to make sure that you are all aware of the AWS Security Center. It's aws.amazon.com/security. This is where we make all information available on what we are doing to provide guidance on how to build secure systems. We also have security bulletins here. I have recently am beginning to develop plans on how to revamp this and how to actually expose a whole lot more information here than we have right now. So if any of you on the call have any ideas or suggestions or thoughts about what you'd like to see, I'd be very willing to entertain those, and we'll have contact information for everyone at the end of the call here. Our goal is to be as transparent and open as possible so that you have all of the information you need to make the right decisions about what to do with AWS, and you can be confident that security is our #1 priority, and that ensuring the integrity of your data is very critical to us. People often ask about how they can be compliant with various regulations in AWS. We continue to be compliant with Sarbanes-Oxley. We have a white paper that describes how to create HIPAA-compliant applications. This is an anonymized case study of a customer who's actually done this. We have a SAS 70 Type 2 certification that is now complete, and we are in the process of doing the second round of that. And we are now also in progress with ISO 27001 certification as well. And then finally, the last thing that I would like to point out is, we frequently mention to customers that for confidential or sensitive information, you should encrypt it before you send it to us. It's fashionable to bash encryption right now. I don't know why. Maybe this is because it will guarantee you, somebody will blog about you or whatever. I don't know. Encryption remains one of the most valuable tools we have for helping you keep data private. It keeps the bad guys away from your information. Digital signatures are equally important because it helps you provide for the integrity of that information. Encryption is critical whenever you give your data over to a third party. Now, that means you have to manage your keys. Key management is not very hard, but there's a little bit of a challenge when it comes to that. You can choose to do that yourself, or you can hand key management over to a third party. And this is where I'd like to turn the conversation over now to Michael and our partner, RightScale, because one of the things he's going to help you understand is how his value add that he brings to Amazon Web Services is helping you, among many other things, manage those encryption keys when you decide to use AWS to store your information. So, Michael, take it away.
Thanks very much, Steve. And I'd just like to congratulate Amazon on the incredible pioneering you've done, of course, in the cloud and continue to do. And really the new model that you're talking about here, what we're seeing, I think, on this call and from all 3 companies and others in the cloud is a new evolving model that really provides opportunities for new levels of security that we haven't seen before. And what I'm going to speak about specifically is how RightScale as a management environment can address a different layer of security concerns. Security, after all, is a kind of a layered cake proposition, and how RightScale can help organizations address the people aspect of security, the credentials that people have to use, how those are safeguarded, management of software that relates to security, all the way through to different deployment environments used as a security technique, as well as different tools that can be used in architecting security solutions. What you see here is just a quick slide showing where RightScale fits in the world of cloud for those who are a little bit new We're a management platform that lives on top of infrastructure as a service. So that red rounded rectangle at the bottom, those are different cloud infrastructures. For example, as Steve mentioned, the 4 different regions that Amazon implements as separate clouds. And RightScale is a transparent, open environment, but at the end of the day, it's meant to deliver automation and ease of use while allowing flexibility. What we aspire to, this is just a bit of a chart of all the different functions that RightScale helps you perform. It's really supposed to be an environment that you can live in from start to finish for managing all your cloud resources, really starting with architecture and design through dynamic configuration and management of systems, a way to control your users' permissions and access, as well as tracking costs by account and by project. An environment you can codify your best practices approaches to everything from security to how you run different applications in your organization, and giving you portability across different cloud infrastructures, which is important, for example, for disaster recovery. Specifically focusing on security, I'm going to talk about these different components that all work together at a management layer to help improve the picture from a security point of view, and I'll just dive into them now. First one is around account permissions. So here what we're talking about is really the ability to separate privileges for different users. We all have individuals that perform different roles. In this example, we've assigned to different individuals in an organization roles concerned with, for example, a designer. That might be a programmer or a tester, a QA person. They really want more open access for kind of a sandbox access where they can do what they want in a test and dev system. There are usually individuals who are more observers, they're managers or tech support reps or maybe auditors who want to be able to see what's going on in the usage of the infrastructure but not necessarily affect it or change it. And then there are actors. These might be sysadmins, for example, operations folks who are assigned the duty of managing an operational system that's in production. Here's a picture of what that looks like. You might have an organization. It's really a many-to-many relationship between individuals in the organization who belong to different teams and different accounts, accessing a whole multiplicity of cloud resources. And really the best practice that's being enabled here is the ability to grant access to individuals only as required to perform the business function that they need. Especially it allows limitation of actor and admin privileges, and it allows an organization to individually discriminate between different user accounts. So each user has their own account. The privileges for that account are controlled and assigned individually, and you don't have to share credentials and other security sensitive information. Another component or tool in the toolkit of dealing with security is the notion of partitioning resources. So from a very simple point of view, you can allocate 2 different Amazon Web Services accounts and 2 different RightScale accounts. For example, one for test and dev and one for production. Let the developers and the QA folks kind of go nuts and have free access to the test and dev account, but be much more restrictive and granular with regard to the production account. And one of the issues that this brings up is the notion of how you move resources, definitions of how server templates run, security groups, etc., from one environment to the next so that you're achieving separation but still ensuring reproducibility of how the system runs. And this is just a picture of how that might work. Little screenshot of the RightScale Dashboard. In this example, it looks like a scalable website with a redundant database implementation. And what it shows is that you've got a completely separate account on the right-hand side for production, and the componentry that defines all of the servers in that picture at the bottom can simply be shared and duplicated across to the other environment where different security groups and security settings apply, and different individuals have access. So it's a very controlled kind of sharing. Here's an example of a screen where an individual rule is being set up using the Amazon Security Group capabilities inside RightScale. And I think in this particular example, it's an example of a rule, for example, for a production deployment, where we're setting up, I think in the first line there, SSL access only to the production servers, as well as it looks like ping, etc. access. And then in the blue group, we're separately setting up the ability of intra-cloud or inside the Amazon cloud, the ability of the app servers to have more access to what might be some web server front ends here. Another aspect that's really, I think, enabled by RightScale that's very powerful is the notion of being able to manage credentials without sharing them widely across an organization, so that your AWS keys really can be mediated. They get registered once in the dashboard, and then access to those or usage of those is doled out to the different roles in different RightScale user accounts without revealing the full credential. And so what that enables is the ability to safeguard application passwords, and there's actually a special type of entry or variable inside the RightScale system called a credential, which, as you can see on the right-hand side under that little gray database window, is shielded from widespread viewing. So again, it's a way to layer or mediate the ability of users to perhaps utilize a credential without having full visibility into it. Another tool that you can use in the management system is around automation. So this is a very different kind of orthogonal view on things, but we all have to run security patches, right? It's one of the major activities of security personnel, and RightScale has the ability, for example, to run a script or a patch across a whole farm of servers simultaneously. So it really helps automate the ability to keep, for example, security patches evenly up to date across your entire production system. There's also a capability within RightScale to pass, for example, passwords or keys into instances at boot time through the special mechanism of how the RightScale core system communicates with EC2 instances as they're booting up, and that information never gets stored on disk. So if one of the running servers that used that key information is compromised for some reason, the key material is never stored on the disk on that instance, and so it's not accessible at all. And finally, with regard to automation, one of the recent announcements we made was the opening up of the ability to completely audit and duplicate the building of raw images and server templates in RightScale from the very lowest level up. This, for example, was really important to our customer Eli Lilly, who needed to completely audit the process of building these images so that they could ensure compliance with their own internal standards and regulatory issues that they needed to meet. And what they're really able to achieve through that is the full audit compliance, and at the same time building up a kind of a self-service infrastructure that they provide in a simpler interface, using a simpler interface to RightScale to business users within Eli Lilly. Final area has to do with monitoring and how that ties into our alerting system and how that can be used to help strengthen the security framework that an organization employs. One is around security analytics. So RightScale is constantly monitoring the servers that you run under RightScale, and you can set up both kind of very common monitoring metrics around hardware metrics like network bandwidth and disk and CPU usage, as well as custom metrics. And the basic point is those can all be fed into a system with rules and policies that dictate where and when alerts are sent out to your system administration or security personnel. So you can monitor, for example, unusual network behavior that might indicate a DOS kind of attack. I would mention, by the way, Amazon has really state-of-the-art DOS prevention on the edges of its system, but nevertheless, this is there as a backup. Or disk and CPU usage that might indicate, something unusual going on your systems. Same with intrusion detection. You can set up alerts for number of users logged in. So if you're expecting nobody to be logged in, you can be alerted when someone does. Same with network connections. And then intrusion prevention is another area that alerts can help enable monitoring with regard to intrusion prevention. So if, for example, you want an alert sent when an encrypted volume is unmounted, you can have that. When a machine is shut down or a firewall closed off, you can have an activity escalated, which means that RightScale can either take an action or alerts can be sent. This is just a picture here of what automation looks like in our system. So you've got a couple of graphs. The top one is HTTP traffic, and it shows, for example, it's actually synthetic traffic, it's fake traffic. So here we have some load machines firing in a sine wave over 90 minutes traffic. And what you see on the bottom graph is what's happening to the CPU of a particular server. In this case, this example is not around security, it's around just auto-scaling of servers. But what you can see there at those various points called out by the arrows is as the server got busier with the blue representing CPU busy, it finally reached a threshold. An automated action occurred, including an alert. Additional resources were brought on, freed up that server, so you can see that little drop around 9:20. The rest of the traffic was shared across a broader base, and then as another threshold was reached of idle time, the extra resources were taken offline automatically, and the CPU load pops up. This is just an example to show really that these alerts can be set for many different reasons, and for the purpose of this webinar, it's really focused around security issues. So there's a lot of sort of very powerful plumbing that can be brought to bear at the management level. And later on, I'm going to pass off in a moment to Bernard to talk about HyperStratus's layer. I'll be joined by Tony Spataro, our security specialist, who's focused 100% on security at RightScale, and he'll chime in during the Q&A session to help answer questions. Would encourage you to keep filing those questions as the webinar goes on. We do have people online answering them. And with that, I'll pass it over to you, Bernard.
Right. Thank you so much, Michael. And really what we've seen through both Steve and Michael's is there's this incredibly powerful security capabilities. And the key thing, just to reiterate kind of this slide, going back to it, is it's a shared responsibility or a shared ability to implement those things. And you have to put in place measures from the application layer all the way down to define and automate and mechanize those things through RightScale to make sure you're taking advantage of the services that Amazon provides. And if we go on to the next slide, what we're going to do is drill down onto the 6 crucial areas. So we've sort of touched on this through the other presentations, but when we work with companies and work with clients, these are the areas that we really focus on at the application layer to make sure we've got these defined correctly and implemented correctly to provide the best possible application security. Security groups, key management, network security, which is actually traffic. So do you need to encrypt your traffic both into the application but also within the application, intra-application traffic. Storage protection, what level of encryption or management do you have to put in place for the storage in terms of your database or on disk or in one of the services that Amazon provides like S3. Intrusion detection, what do you have to put in place to make sure that your software components are being protected, that you're aware of any traffic trying to get at them, any kinds of traffic that rides and looks like it's legal but in fact isn't. You need to be alerted about that. And then how do you manage your application code? How do you integrate it in with your source code control system so that when it's brought up and injected by RightScale, that you've got the right integration there. Now, in today's presentation, we're going to drill down into just one of them, which is security groups. We're going to talk about the best practice around them. But if you have questions about the other 5 areas, I will have something at the end about how you can get more information on all of them to get, be able to address all 6 of those areas in terms of the stuff. If you look at the default security group partitioning, Amazon provides a single security group called default, and it's ultra secure. It has absolutely nothing open, and so you have to deliberately open up ports to make it possible to communicate with your application. And this can be kind of challenging. I saw a funny thing on Twitter just yesterday, the day before, where someone said, I brought up my application, but I can't seem to get at it. And somebody said, have you opened up any of the ports into your application? And kind of, a bit shamefacedly said, oh, no, I hadn't really gotten around to that. So the default group is closed. A very common practice among a lot of applications is to basically use that group as the resting place for all the ports to be opened. And we recommend against that. In fact, our recommendation is the default should be left alone and not have any ports open in it, and additional security groups should be created. So overloading is really a problem. And if you do that, it presents a security risk because if you put all of the ports that your application needs open into that one group, every instance can talk to every other instance, and that presents a security risk. Best practice is to layer your application and keep protection within the application to make sure the traffic only goes to where it's supposed to go and not into other instances that shouldn't. And if we go to the next slide, we can take a look at a description about that. Here is a better way to go about it. You take your security group and you partition by application role within the application. And in this example, we show on the left-hand column, port 22. We have a single security group with that port open. And in fact, one of the things that Amazon provides is the ability to really crimp down on what IP addresses can get at certain security groups. And so the best practice is to take that all-important SSH one, which is access into the instances, into the guts, basically root access to do anything with them, and really confine that to a trusted IP address, typically at your location. And so that way, no one from any other area, no other IP address can get at that and get that all-important root access. And then turning to the application itself, as you see, we have 2 different columns here. One security group really is just for communication between the web and the application layer. And this is really important because the web layer is where traffic comes from the outside world. That's where the malevolent traffic is going to come in. The people will be coming after your instances, absolutely. That happens any place that you make a web application available. And so if you confine the traffic between the web area, the web layer, and the application layer, that means there's no way for somebody to attack the web layer and get into your storage, which is, typically the most crucial thing is the data within an application. There is no way to get traffic from that web layer into the storage layer. And then a second security group, which is the third column here, is defined to talk about between your application layer and the storage layer. And so traffic can only go between those things. And the only layer that can get at the storage layer is something that you've written, your application. Now, this is a bit simplified in that you can end up with many other security groups associated with if you have some management instances running around your application, if you have other servers that are doing different things, like you might have a intrusion detection running on a separate instance that's capturing traffic from the intrusion detection systems running on these individual instances. You can end up with, in a typical application, we run into something on the order of maybe 20 or 30 different security groups. And so it's a lot of security groups to keep track of. And if we go to the next slide, we can see where this gets even more complex, because the best practice is really to partition security groups by the application stage. We're working with a large financial services company that does investment analysis up on Amazon, and defining with them, we're implementing security with them, working with them. And part of what we've been doing is really helping them identify the life cycle of their application and what security groups should be available for those. So we really partition those security groups so that the dev instance of the application, which is maybe 8 or 10 different instances, all have certain access, roles that can get in there. But when you go into staging and production, you start really clamping down on who has access to those things. So you end up with a different set of people who are allowed to get into those security groups. And so, in a project like that one that we're working on with this financial services, we've probably got on the order of 60, 80 security groups that have to be applied depending upon the instance type and the stage of the application. And this is where we really take advantage of RightScale, because we're able to design and configure the application with RightScale so that literally changing one pull-down menu applies the right set of security groups to these different stages and the different instances, which makes it so much simpler and so much less error-prone. This is really, really crucial. So this is kind of a vision into managing security groups from an application level, and kind of a set of best practices around how do you partition, how do you define which security groups you should use, and so forth. So your obvious question is, well, what about those other 5 areas? I want to know the best practice for all of them. I think when we go to the next slide, we've got a way to go about that. Well, let me sort of sum up about this layered approach. We've had great information from Amazon and RightScale and HyperStratus, and it's really working together to make sure that all 3 layers are defined consistently, implemented properly, and integrated in a way that they work together. And so the key is thoroughness and consistency across all those layers. Amazon has a robust security framework. RightScale automates and implements consistency. I mean, I can't emphasize enough how much it's really important. When you start really putting in best practices around complex application topologies, especially scalable web applications, absolutely crucial, because otherwise you're not going to be able to keep track of it manually. You will make errors that will leave your application vulnerable. Best practices is really a way to reduce risk. We work with clients to make sure that that's done properly. And if we go to the next slide, now we'll talk about how you can get more information. The recommendations are, identify the application security requirements, understand the AWS security framework, really crucial, define the requirements that are implemented and automated by RightScale, integrate the application security best practices with that entire overall framework, and then ensure your application project management and IT processes reinforce top-to-bottom security. I mean, this is an input to the project, not a bolt-on afterwards. We're brought in many times by companies that, sort of say, well, it's up and running, but we're not really sure we've got it right. And then, that's a tough way to backfill security. So we suggest that, that's part of the project plan from the beginning, and that you set down and really understand the security and implement it. If you'd like to learn more about the security groups and the other 5 areas, we'd be happy to have a free conversation with you. Compare your security to these application security best practices, our checklist. We'll cover all 6 areas. It's only an hour. If you're interested in finding out more about application security best practices, how you look at Amazon and RightScale and make sure that you're doing the right things with them for your application, defined by the requirements you've got for your specific needs, you can go to this URL and request a discussion. Or if you want to pursue this even more quickly, you can definitely give us a call. Be happy to talk to you. And I think with that, at least we're ready to move to questions.
Great. All right. Thanks, Bernard, and thanks, Steve and Michael. That was a very informative overview. I can tell because we're getting a lot of good questions coming from it. And that's an attractive offer you're putting out there from HyperStratus. So now we'll start with the questions and answers. Remember, you can keep submitting your questions now. We'll try and get to them all live. If not, we'll get to them via email after the webinar. So let's do a first question here for Steve and Amazon. Steve, why don't you go ahead?
So a number of them have come through. I think I can probably hit several of them all at once here. I've got a lot of questions about VPC. Is VPC in Europe? Yes. We recently announced that. Is it possible to connect the VPC from VPC to S3? Not currently. You would have to go from VPC through your CorpNet out to the internet to S3. If this is a requirement for you, please let me know. Third question is, how do you use VPCs without having your own network infrastructure? We don't have a mechanism for that right now. We do need a customer-side gateway that supports an IPsec tunnel mode security association. You could probably do that with a Windows RAS box as long as it does support the standards. We haven't tested it, but I can't think of any reason why it wouldn't work. And the final one regarding to that is there a guide to running AD, Active Directory, in VPC? Yes, there is. If you look for ADFS and EC2 Federation, just search for that on Google, you will find a pair of documents, one published by Microsoft that's a conceptual guide, one published that's by us that is a how-to guide on how to configure ADFS on public instances. If you just want to run Active Directory inside of VPC, there's nothing special to do there. Just stand up a machine, DC promo it, and you're all done. It's literally that easy if it's in VPC. So I do have some other questions. I don't want to take all of the time, so let's hand it back over to the other guys to lift and get some of theirs next.
Okay, yeah, we'll come back to you for sure. So Bernard, it looks like we've got a question for HyperStratus. Do you want to go ahead and take that?
I think that the question you're referring to is the one that came in around the security groups and the intra-cloud and source groups. Is that accurate? Is that the one that you're
Yep.
looking to? Yeah, well, it can be challenging because within Amazon, they use dynamic IP addresses internally, and so that can be a challenge of how you define those. I mean, one way you could do it is a pretty sophisticated arrangement. We wouldn't necessarily recommend that. Another way that you can go about it is a technique where you use an external DNS service where these instances register and use elastic IP addresses. You then can query against that, find out the instance. You can then allow traffic on that basis. That's another technique that we use. It can end up being, I think, sort of what came across in the discussion about the security groups is a lot of power. You really need to sort of understand what the capabilities are so that you define them properly, and that's around that elastic IP address and the DNS dynamic registration. But that is how I would go about that technique.
Okay, great.
Can I interject here? I think if I've grokked this question correctly, on a security group, what you define is the destination port numbers and the source IP addresses. So what traffic can, what ports can the traffic arrive at on the inbound server, and where can it come from? There are two ways to define the source of traffic. One is this, an actual IP address, right? But you can also indicate that the source of a traffic is the name of a security group. So for example, you could build a virtual 3-tier application by creating the web tier security group allowing inbound traffic from the internet, and then your application security group, you wouldn't say that inbound traffic comes from a group of IP addresses because those would be the web servers whose IP addresses could actually change, right? But instead, you would say that the inbound address is actually the name of the web application security group. So as servers come and go into the security group, you don't have to rewrite the security group rules for the application tier. I actually have a visual for this. I could probably post that. I'll put that on the Amazon Web Services blog maybe later this afternoon, and people could see that. So you can get a visual idea of how that would work and how you would define the security groups differently. Does that answer the question?
Thanks for elaborating on that, Steve. I think it helps to get elaboration from all sides.
Okay.
Okay, and then it looks like we've got a question now for Tony with RightScale. So Tony, do you want to go ahead with that one?
Absolutely. Alrighty, the question was, is the key material in the environment of running processes? And this ties back to what Michael was talking about earlier, about using RightScale to inject key material at boot time so that it doesn't reside on disk. So the answer is really it depends on your implementation. So to make the answer more productive, let's consider a specific implementation of disk encryption. Let's consider a Linux machine that has mounted an encrypted volume. Now, when I mount an encrypted volume, I specify my passphrase for encryption on the Unix command line at mount time. After that point, the key is derived and the key material resides in the kernel memory. So if I were to mount my encrypted volume using a write script, inject my passphrase as an input, then the key material wouldn't reside in user memory, nor would it reside on disk. It would, of course, stay around inside kernel memory on that instance until the instance went away.
Okay. So now we've got the next question for Steve. And Steve, it's actually almost noon, so that's our end time on the webinar, but we'll keep going because we're still getting a lot of good questions. So if people want to hang on and listen to the question and answer beyond the top of the hour here, please feel free, and also feel free to keep asking us more questions. We'll hang on as long as we've got a good number of people on the line, which we do.
Okay,
so Steve, why don't you tackle a new one?
All right. Two real quick ones. One, Canadian customers not allowed to use AWS in the U.S. When are we opening a data center in Canada? We don't have plans for that right now. My best suggestion would be to use the data center in Europe. Slightly related to that is, can an Amazon operator see what's in memory in an EC2 instance before it is terminated? My clients are worried about having their data on Amazon infrastructure. As I mentioned in my portion of the talk, we have procedural as well as technical limitations against what our operators are allowed to do, and we place some technical controls such that looking at what's in memory is prohibited by policy, and if an operator were actually to do that, what they would see doesn't really make sense because of how we isolate the VM from the physical machine in our extra secret sauce that we add to the hypervisor. So I would offer to you that that's probably not something you really should worry too much about.
All right, and now we've got a question for Bernard at HyperStratus.
Right. So there's a question here that came up that around key management and if someone leaves or someone is fired, how do you protect against them still having access? And part of key management, which is one of the 6 crucial areas, absolutely, is having centralized management, centralized storage that is secure, and then having a regular rotation of keys so that they, so that something that's leaked out at a certain point, only has a limited lifetime of vulnerability. But then also really important is the ability to, quickly respond to those key differences. In other words, if you have to change the key, how do you quickly respond to it? And really crucial to that is using some sort of centralized management mechanism. RightScale is very good because you put the keys there, and then it's very easy to re-instantiate your instances. They then come up with different keys if you change the key, and somebody who has the old key can't get into them. So that's one way. And then, in terms of, then you've got to figure out how do I distribute those keys out to individuals, and that's really another part of key management, is how do I make sure that the people who do need to get at those instances have the updated key on their own machine if they need to get in from their own server. You've got to have a way of distributing that, or better yet, a centralized location where they essentially kind of check out those keys, and that's a mechanism. And those are all ways that you protect yourself against a vulnerability of, someone leaves, gets fired, is unhappy, and still has possession of a key that would give them access to your application. So that would be a recommendation around those, around that question of how do you protect yourself against vulnerability with keys.
Okay. Thanks, Bernard. And now we've got another question for Tony at RightScale.
Okay, so this is a question I've actually seen pop up a few times, saying that, you mentioned that you can check incoming traffic from a particular IP or from an IP range or security group, plus a port, but not necessarily from another group and a specific port. Another iteration of the question has been, security groups don't give me quite what I need. So I think I'm going to take that more general question and suggest that EC2 security groups are one layer of network authorization you can do as you architect your application. But don't forget that most of the time your instances themselves have a perfectly good host-based firewall you can leverage. So for instance, I might open up my database server to people in my app server security group, or sorry, instances in my app server security group, but then I would use my host-based firewall to only open the MySQL port or the Postgres port. The host-based firewall is a useful tool that you shouldn't underestimate because it's capable of applying very specific and granular authorization rules. Only so many connections at a time, only at certain times of day. The sky's the limit with this one. So by taking a layered security approach, you can usually get exactly what you're looking for.
Okay. Well, we've still got a bunch of people on, and the questions are flowing. So, Steve, how about you take one for Amazon?
All right. Somebody said you recently talked about something called the Simple Encryption Service. What is that? Is there any additional info? I think the person is referring to an idea that I floated when I was speaking at the RSA conference. It was a hypothetical question. It was an attempt to throw out an idea and elicit people's response. And I gave the idea a name. I called it the Simple Encryption Service, where we would have a mechanism by which customers could generate and request keys that used to encrypt data. It was more the thought exercise. There's no product announcement there. That's why I concluded my portion of the talk with a reference to why I believe encryption is important, and then suggesting that for those who want to rely on a third party for key management, that RightScale is a solution that's very adequate for that right now. Another question asked about FISMA compliance. Is there any progress on that? It is something that we're looking at. We can't really say anything more than that right now. Please keep an eye on the Security Center for when that's complete. And then also, before I forget and before people disappear, there have been a number of people who wanted to contact me privately. Since my job basically is to talk to people about AWS and get people excited about it and help people know what to do with it, I'd like to offer up my personal email, well, my work email, to those of you who are still on the call. It's S-T-E Riley. Think of it as sterile with a Y. I know not the best email, but it's what I've got, at Amazon.com. That's S-T-E-R-I-L-E-Y at Amazon.com. And please feel free to write to me, tell me that you were on the webinar, you have additional questions, and I'll do whatever I can to get answers for you. So let's toss it back. Who's next?
Okay, Bernard's up next.
Let me take my thing off mute here. Yeah, so there's a question there about code management, and you mentioned that as one of the key things. Could you give an example? And really, this is about how do I get code in and out of my application instances. And RightScale automates that through injection. But the question is, how do you get the right code to RightScale so that it knows what to inject? I'm talking about your application code, not like the operating system or something like that. A couple of different ways you can do that. One is it's easy to have your instance directly call out to your source code control system. Another way is you can actually do a staging of the code up into S3. With the, we were working with another client, another financial services company actually, very concerned about security. I mean, highly, quite stringent about that. And we ended up doing a stage up into S3 because that way when the instances were dynamically assembled by the injection of the code, they could be assured that there was no way to tamper with that code as it was transmitted across the internet. So there's at least a couple of different ways to go about it. It kind of depends on what requirements you got, if there's any compliance or security issues. And also, having it located within Amazon can help you in that you're not faced with the potential of perhaps some sort of internet outage, not with Amazon's connection to the internet, but with your connection from your source code system into the internet. So if you have the code located locally, within Amazon, that obviates that problem. So that's a way that you can go about that.
Thanks, Bernard. All right, Tony, we've got another one for you for RightScale.
Absolutely. The question was, are there plans to integrate multi-factor authentication for the RightScale dashboard itself? The answer there is short. We're looking into it. We're thinking about it. So I will take this opportunity to slip in one more quick question, which is the recommendation is to lock down instances to SSH access. But in order for RightScale to function, isn't it necessary to open up SSH so that RightScale can jump in the machine and perform management functions? And I'm happy to announce that as of RightImage v5, that is no longer required. We can actually manage your machines without getting SSH access to them. And for older versions of the RightImage, we also have solutions. I refer you to our technical services team to help you out with that.
Cool. All right. And why don't we go to Steve for our last question. I think you might have a couple lined up there that he'll quickly go through, and then we'll call it a wrap.
Yeah, a couple quick ones. Question about instance isolation between public EC2 and VPC EC2 in the same availability zone. There is strict isolation. If an instance is in VPC, it can only communicate to your CorpNet. It cannot communicate to public EC2 instances even in the same availability zone, and that is by design. So you will have to route that traffic from the VPC instance through your CorpNet out to the internet to the public EC2 instance. The other one was how is the isolation between the VMs ensured? I covered that briefly in the talk. The security white paper has a whole lot more detail on that, and if you want to research that, and I would recommend you go there. And then finally, the last one was about if the keys, AWS secret key and access keys are actually included in an instance that got compromised, what do you do? We have a key rotation feature that you can use to take advantage of that will allow you to establish a new set of keys and then give you a small time window in which you can transition your existing instances over to those new keys and then finally terminate everything that's using the old one. And that covers all of my questions.
Okay. Well, it looks like we just had a couple more come in, so we decided we'll answer them. We've got such an active Q&A line this time. So, Tony, it looks like there's one for RightScale, and then after that, Steve, there's still one for you on the AWS side. So, Tony, why don't you go ahead?
Okay. So the question was, and this is sort of reiteration of an earlier question, what are the best practices for securing an AWS secret access key and key identifier when I need that to actually implement my application? A good example of this would be if I'm using S3 as a backing store and storing assets on behalf of my application's users. And this is where Bernard's and Steve's advice to create multiple planes and separation of privilege comes in very useful. What I do in this case is I would launch my instances that comprise my application using a particular set of AWS credentials and a particular AWS account. But that application's use of S3 would occur under the guise of another AWS account with another credential. By having two planes, we ensure that privileges to launch or terminate your application are not commingled with the privileges to store resources or retrieve them.
Okay. Steve's got an easy question, and it looks like he's actually going to pass it over to Bernard. So Bernard, why don't you go ahead and answer that question about the industries that are using the cloud?
Yeah, so the question is, what industries are adopting cloud computing, and maybe Amazon in particular. And Steve said, well, everyone is, and I would agree that within our client base we see a wide representation. As I mentioned, we've got financial services companies. We're also a lot of media and entertainment because they like to take advantage of the S3, very large-scale, inexpensive storage, and also Amazon's CloudFront service, which is a content distribution network. So it enables them to, locate content, and it's done transparently. So that's media and entertainment. We're actually working with an education company that is, got a global presence that wants to deliver content. So, what I would say is it's either, typically right now what we're seeing is industries that traditional models don't work that well. So, for example, like this content distribution kind of stuff, it's not that easy to do that within your own infrastructure. We see industries with a lot of websites or very scalable websites. We worked with packaged consumer goods, or consumer packaged goods, who have a lot of websites, to cover all of their brands and run various kinds of marketing campaigns. They need to scale up and down. Well, that elasticity of Amazon works really well. And then we're actually seeing traction within financial services around certain kinds of business intelligence. In other words, I want to do analysis across data, or things like that. So a broad range, but primarily organizations, industries that the traditional computing model of internal data centers doesn't work very well because of scalability or seasonality or something like that, or organizations that want to take advantage of the kind of global scale they can get through a cloud computing environment.
Mm-hmm. Okay, thanks for that, Bernard. So with that last question, we're going to wrap up the webinar, and I want to thank everyone for attending. We hope that you found it useful. And there will be a recording of the webinar posted most likely by tomorrow, so check back tomorrow. You'll also get an email letting you know it's up and running, and that's found at rightscale.com/webinars. And then please remember the offer from HyperStratus, which is to give you an hour of their time to go over their 6 security essentials. So with that, thank you to all the speakers and the participants on Q&A who will actually be on. If you want to send them questions once we get off here, they'll be live for a little bit longer on the text Q&A line. So go ahead and send more questions if you have those. And thank you, everyone, for today's webinar.
Thanks very much. It was great to talk to all of you.
Great. Thanks everyone.
Great.